Hello guys, this is Pawan from Electronics. So today I am here to tell you about how we can use standard peripheral libraries in STM32 based microcontroller. As in my previous tutorial based on STM32, you have seen that we have used CubeMX. CubeMX is very easy, means like to generate code from CubeMX is very easy, and I think you have seen there how we can easily generate the code. But to understand how basically things are working, I would suggest just please go to this standard peripheral libraries. I know it was discontinued from ST microelectronics, but still if you'll use these libraries, you'll learn a lot about how registers are working in STM32 based controller. So okay, I'll just show you one toggling program with standard peripheral library, and here we are choosing STM32L100 discovery board. So we have to choose a standard peripheral library based on STM32L1 only. So we can download that library from this ST official website itself. You can see this is st.com embedded, and here is the package. And if I'll go scroll down here you can see SW-STM32077. This is the part number of that library. You can click on get software, and you have to log in and all. Then you will easily get this library. So this is here also you can see it is written that STM32L1 access standard peripheral library called this covers 3 abstractions level. So these things and all you can just read, and you can come to know how these things are working. So I'll just show one toggling program using this library, and I'll use this 32L100 discovery board. So okay, let's get started. Here we have the Atollic TrueSTUDIO. As I have told you, I'll be using Atollic TrueSTUDIO only, but you can use Keel and any other software where we can use this ARM Cortex M series based controller. So okay, first we will just go to the file, and here just go to new, and we'll click on this C project. Okay, so here we'll choose embedded C project. I'll give the name, let's say I will give toggle LED, fine, and will not use default location. Let me give the location. So I'll go to the browse, and here we will go to this my work, and I'll just click on this make new folder. Here I'll just click TOGGLE, again same name, LED. So this name we will give, this is toggle LED. So this toggle LED, I'll just click on this toggle LED, and I'll click on OK. So here we have the location now in D partition. In my work we are just we have created one toggle LED folder, and we'll click embedded C project is selected. We'll click on next, and here we have to choose the right board. I'm using STM32L1 based series, so I'll just click on that, and here in boards I'll just click this discovery board. I'm using STM32L100 disco, and here you can see we have flash is 256 KB and RAM is 16 KB. So thumb 2 is there, little endian method we are using. Now I'll click next, and we can just continue with our next. Here debug pro, we are using debugger ST link, so again we'll click on next and debug and release. Let it be enable, finish. So one snippet will be generated through this software. So here you can see it's just building the project, because first time it is taking this time. So we'll just get some initial things like this library and the main SimSys library. This is called STM32L1XX.h, and then this is set sysclock 1 declaration is there. Definitely there is a calling set sysclock and system core clock. Set sysclock, you can see here in main also only we can get the set sysclock, and Then same way another is system core clock. This will be in system STM_STM32L100.c. in this file we have this thing. Now what will we do? We will just include those standard peripheral libraries. So here for toggling purpose I am using only two files of that standard peripheral library. First I will show you the standard peripheral library. I have already downloaded that thing. This thing is standard peripheral library, STM32L100 standard peripheral driver. So here are, you can see in source file we have this much of C files are there, RCC, PWR, LCD, I2C, GPIO, so many things you can see. Same way the include files of the same you will get all the files related to C file. We have correspondent H file is also there, RCC, and here GPIO is also there. So we only need this GPIO and this RCC. So we'll just take these two, and source file also we need those two things only, GPIO and this GPIO and this RCC, two files we needed. So these four files will include. So what will I do? I will just go to the driver, and here stand in HAL we don't have anything. Anyhow we are not using HEL. So HEL part, let's click on driver part. Now I'll just do one thing. We will click on this import, and in file system we will just browse from where we need to get those files. So I'll just get that file from SPL L1. Okay, so on this SPL, and we'll click OK. So from this we'll just select all, and I will just put in toggle LED drivers. Fine. Okay, toggle LED drivers, it will be just we will copy. We have taken these four files, finish. So here SPL, these are the files. Now in main we have to change for some of the things for this code to make it blink one LED. So as I have already written some of the commands, so I'll do one thing. I'll just go to on that part, main itself. In my previous code I have written this thing. So main.c, I'll just copy through this, add it with notepad++, and I'll just Control A, Control C. Here I'll paste it. These things will be there. Sys clock, system core clock update, every function will be there. Some of the additional things I have added, I will just show you that thing. So I'll just copy that. So here you can see now in previous page we don't have this thing, so we have just included these two files, and after that we have made another declaration of one function that is called configure GPI out, because we have to configure one output pin, and here we have declared I variable, and I variable is already declared on that file as well. These things are common on that file, the previous file, these things are there. So I have added this thing, configure GPI out. GPI 8 pin is internally connected to one green LED in our 32L100 discovery board, so that's why we have taken this argument as GPI pin 8, and GPI C we are using PC8 pin is there, that toggling pin. Same way you will write GPI toggle bits, GPI C, GPI pin 8, and then one delay, just using one for loop, because simple. I just want to show one blinking thing using this. Now in configure GPI out part, you can see we have configure GPI out function. This thing is also there. We have written this. Now in RCC ASB peripheral clock command, you can see this RCC ASB peripheral, we have to set the clock. So that I'll show you the debugging part first. Let me compile this. So we are getting fatal error of STM32L100 GPIO.h. So what will we do? We will just include part. We did not give path to that SPL, that's why this thing is coming. So here you can see toggle LED include. This is for SIMSYS, this is also for SIMSYS, this is for HAL. There is no file, and LED source file. So we'll go to the project, we'll go to the build settings, and here we'll go C tunnel paths and symbols, and here we'll add path for this. We can go to workspace and toggle LED, driver, and SPL. This SPL4 files are there. We can click OK, and we can add this thing. So this thing is also added now. We'll click on apply now. OK. Now if I'll build it again, so we'll not get that fatal error and all. So here we are getting this HSE startup timeout. So this HSE startup timeout, as you can see here, it is written in rcc.c. So what I will do, we will just first we'll look on about HSE startup timeout. And another HSE value. So HSE value, we can just declare this thing here. This HSE value in rcc.h only we can declare that. Here we can write. So it will ask that this is readable only. Do you wish to make it writable? So yes. This thing HSE value and HSI value again. So we'll just click this thing here. Now these things are fine. Now I'll just build this thing. We'll again rebuild. Let's see how many errors we are getting. So many errors actually we are getting. Why these errors we are getting? Let me check. So GPIO type DF, if you will see BSRRH, this is register. This BSRRH is not declared anywhere because this thing is discontinued from ST. This BSRRH register, this is old register. So I'll just same way other things are there like this. Here also this register is discontinued. So what I'll do, I'll just pause this video for a while, and then I'll just okay. Now I have just updated the these standard peripheral library files. These two files particularly, RCC and GPIO only, because these two files only we are accessing. Now I'll just build this. So here we will see that we will not get any error. So here we go, we are not getting any error. Now if I'll just go to main, and if I'll just first I'll remove the debug part, I will remove the delay part, sorry, and I'll show you the debugging of our STM32 microcontroller. Has now it's in debugging mode. No, it's not debugging mode. Again I need to debug. So again I'll click apply, and here OK. So now we are just about to debug this. Yeah, it's showing debug. Here you can see. So now if I'll just go to here and set sys clock, it will see which type of clock we are setting. So HSE status, RCCR, startup counter plus plus, these are the things. HSE or HSI, we have which internal clock we are using. So here we are using actually HSI. So here you can see here first these registers. I will just let you know about these registers when I will just make one tutorial based on drivers, GPIO drivers. So these registers I will make you understand. So first you just see these are some registers of our STM32. This means like these registers are there, CFGR, and then other registers are also there like control register CR, So here we go, and now system core clock, you can see here we'll just go to the, we are just line by line, just HSE selected as PLL clock, break, and here we are configuring. So in configuring part, you can see there is a new state is not equal to disable. Then it will be just go to an RC HB peripheral, because HB peripheral is connected to our GPIO pins, this bus HB peripheral bus. So that's why we are just this condition is becoming true, and will come out of this. Now these are the configure GPIO out in function. We are pins from this pins we are getting GPIO pin 8. Now this mode is out, speed is 10 megahertz. You can see we have multiple speeds, 400 kilohertz, 2 megahertz, 10 megahertz, 40 megahertz. So medium speed we are using. And again GPIO type PP, this is a type enum, and this is up, pull up, pull down. We are up, pulling up the register for accessing this. Now this in GPIO initialization, we have to just set all the things what we have required. So we are through this for loop we are just setting those pins which, by using those pins as we are making as an output. So here you can see pin position a bit 2, then 4, this way we are getting. So this way this thing will work. Position will be pin position will be 8. Now again it will just go, and current pin is 0. Here you can see the value because we are just adding with POS position we are getting from this, and by left shifting this pin position. So same way many values will not get. So current pin is 0 again. So this position will be now, so this position will be now 128. It will go till 256 till 65 bit memory, means like till 32 bit value. This pin position here you can see we are getting 8 now, and this current pin is now true, 256. Yes, so all the things we are just temporary variable to update this OSP DER register configuration and all. So these things we are just initializing our GPIOs by just setting these registers. So it will run till we will not get this position 32 bit, means like pin position should be 11. So this should be this 0x10, which is nothing but 20, means like 16, sorry. So 15 bit values are there, that's why 0 to 15. So here you can see now pin position is 16 now, that's why it's just, so it's just bit by bit we have set for the GPIOs of all the registers. Now if I'll come out of this, and if I'll just click on this GPIO toggle pin, now my LED will glow. So here you can see now it's running infinite loop. So I hope you understand this now. Now what I'll do, I'll just will come out of the debug thing, and we'll just uncomment this thing, and again if I'll build, so we'll get delay as well as this blinking. Now I'll just resume this, and here our LED is blinking. I will show you that how it is blinking. we'll move to the hardware. So here you can see this is our 32L100 discovery board. So here you can see blue LED is toggling now as it is connected to GPIO port C 8th pin PC8. So this way we can able to make blink using standard peripheral library. Now if I just change the pin number to from 8 to 9 and toggling also from 8 to 9, and now if I'll just build this thing, now I'll just terminate it and my code will be changed from blue LED to green LED. So we'll again move to the hardware and see how things are changing. As you can see now green LED is toggling because that is PC9, means port C, 9th pin of our discovery board. I hope you like this tutorial, as we are just doing this thing using standard peripheral library, which is in which we can learn lot of registers how they are working. So I'll just make one video of this GPIO pins operation using only Sims core. So please stay tuned for other videos as well. Till then, thank you guys, thank you very much.